Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. Now I am going to explain that numerical application. Here it is introduction part 2, where I am going to explain activation energy and how all are related to temperature difference and different facts. So here what is activation energy? Extra energy that is supplied to the reacting molecule in normal energy state to make equal to threshold energy. That means the energy which is required in the normal energy state to become to equal to threshold energy. That means activation energy equal to threshold energy minus normal energy. Here activation energy means threshold energy and minus normal energy reaction. That is why it is written to make equal to threshold energy. Photons of light, that is one example. Photons of light E equal to h nu, and that is the example of the source of activation energy. So here we can observe what is activation energy. That means threshold energy minus normal energy. And after that you can observe what is threshold energy, which is represented by E0, and here that means to make the collision effective. Threshold energy means collision should be effective. What is the minimum energy required? That is known as threshold energy. What is collision effective? That means it can give product. The collision which of the molecules which can give the product, that is called effective collision, and this one known as threshold energy. So to make a collision effective, that means to give product, what is the energy minimum required, and that is called threshold energy. This energy is necessary to break the bonds. When breaking the bond, if you want to break the bonds between the molecules, you should take threshold energy. Colliding species, if less than the threshold energy, remember, if it is colliding species, if it is less than threshold energy, no collision gives the product. So here it should be more than the colliding species. If more than threshold energy, then only collision possible give to product. Orientation barrier, that means when the molecules will break, that here there should be some orientation. Molecules taking part in reaction that are face each other, otherwise collision will be wasted. That means they prepare to become face to face. Face to face, that means here collision takes place and the product is produced. The energy barrier, so it is the next is energy barrier. The energy barrier is called threshold energy. That means energy at the barrier means to give the activated complex. Here you should say that is the energy of the barrier. And normal energy at the normal energy state, if you absorb the required energy of activation and reach the barrier. When the energy here at the barrier is called threshold energy, and energy required for the activation and reach the barrier point reach, that is threshold point reach, and here the activation energy complex or activated complex is formed. When activated complex is formed, what are the required? Fast reactants plus activation energy, and here it gives an activated complex, that is transition state, which is unstable, and here which is unstable, this is called activated complex, and here energy release, then it gives product. Remember, transition state, or you can say activated complex, where first reactants absorb activation energy, or you can say absorb, or you can say require activation energy to form activated complex. That is the called transition state also. And if it say reaction AB plus C, it gives AC plus B, that is product. When product is formed, some energy that is released. Released means here it gives product. So you can say for the exothermic reaction, what happened? If the energy released by the activated complex in forming the product is more than that of the activation energy. So I told in that before, that means reactants take activation energy and activated complex form. If the activated complex, then energy release forming the product here more than that of activation energy, then it is only exothermic reaction. Endothermic reaction, what happened? If the energy release in forming product is less than, and before that exothermic greater than, more than, and here it is less than the activation energy absorbed by the reactants. So what is the energy released in forming product should be less than the activation energy, that is called endothermic. More than activation energy is called exothermic. So this is the meaning of the exothermic and endothermic reaction. Or you can say, if delta H is negative, that is for exothermic reaction, if positive, that is endothermic reaction. Before that, you should say about forward reaction and backward reaction. Forward reaction, there is energy of activation, that is activation energy, and for backward reaction also, that is activation energy. One is forward reaction, the other one is backward reaction. Here let one example, general example, A plus B, and then it is a reversible reaction, it gives A plus C. For exothermic reaction, that EA forward reaction, that this one is forward reaction F, and here it is F forward reaction, and this is backward reaction. If forward reaction, and this is forward reaction, and this is backward reaction. For exothermic reaction, activation energy of forward reaction is less than activation energy of backward reaction. If remember, if the forward reaction activation energy very less than backward reaction, this is exothermic. Similarly, if the activation energy forward reaction is less than activation energy of backward reaction, then it is endothermic reaction. Here forward reaction activation energy less than backward reaction activation energy. Change in internal energy, then this is the called activation energy. Okay, then change in internal energy, that is delta E. Internal energy mean delta E, and change in internal energy mean del E. If del E, how to calculate del E? That means activation energy in forward minus activation energy backward. How can you get this is minus sign? For exothermic reaction, delta E is minus. For endothermic reaction, delta E is plus. So exothermic reaction require less activation energy than endothermic reaction. So exothermic reaction products faster than endothermic reaction, because here less activation energy required than endothermic reaction. So exothermic reaction proceeds faster than endothermic reaction. Always remember, exothermic reaction always faster than endothermic. Why? Because activation energy of exothermic reaction is less than endothermic reaction. And if you say for exothermic reaction and endothermic reaction, what is the graph? You observe here x, it is y-axis potential energy, and this is x-axis progress of reaction, and this is for exothermic reaction. You can find here EA, forward reaction, is less than EA, that is backward reaction, and difference, this is delta E. And similarly, endothermic reaction, forward reaction energy of activation is more than backward reaction activation energy, and that is called endothermic reaction. And here this is known as threshold energy E0, here E0, and here it is activated complex is formed here, and here also for exothermic and endothermic reaction. Threshold energy is independent of the temperature. Here observe E0, that is energy barrier, and here independent of the independent of temperature, where activation energy is temperature dependent. So after that you can see how the formula activation energy and the temperature related. Before that, you should see what is ARRHENIUS equation and calculation of activation energy. When you know activation energy, then how to calculate? ARRHENIUS scientist who proposed that equation between rate constant and temperature. There is a quantitative relationship between rate constant and temperature, because I told just now activation energy is independent to temperature. K equal to, this is very important equation, K equal to, here K equal to A e to the power minus EA by RT. This is called ARRHENIUS equation, because ARRHENIUS science, that is produced this equation called ARRHENIUS equation. A is the called ARRHENIUS or frequency factor, also called pre-exponential factor. Remember, in ARRHENIUS equation, what are the values of A, EA, R and T? EA is the activation energy, and which represent the minimum energy of molecule possessed before reaction. Activation energy, that is minimum energy when the reaction not started at the time before the reaction. This is activation energy. Then if you see A and EA, that is ARRHENIUS parameter, because the scientist ARRHENIUS who told about A and EA. E minus EA by RT, fraction of the molecule have energy greater than EA. So what is E to the power minus EA by RT? This is the fraction of molecules, and value of energy is greater than EA. And what is T? T is the absolute temperature. Gas constant, the value is 8.314 J K to the power minus 1 mole to the power minus 1. So you know K equal to A e to the power minus A by RT, which is known as ARRHENIUS equation. If you take both sides logarithm, that is ln K equal to ln A minus EA by RT. When this is the result, ln K equal to ln A minus EA by RT. If instead of ln you put 2.303 log, and this is the value, multiply by 2.303, and this is the value. And after that, if you remove the 2.303 both sides, then what is the value? Log K equal to log A minus EA by 2.303 by RT. Remember, 2.303, if you divide in the whole equation, then log K equal to log A minus EA by 2.303 by RT. And here it is also in the form of y equal mx plus c, which gives straight line. Here y equal to log K, and x equal to 1 by t, m equal to minus EA by RT. Sorry, minus EA by 2.303 R. So, and what is intercept here? That is log A. In this equation, when log K, y equal log K, and plotted against 1 by t, that is x-axis, get a straight line. And what is the intercept of this line? Log K, log A. So, here you do one correction. It is not small log A. It should be log A, log A. Or you can write here log R. So, you can observe also before that also log K and equal to log A minus EA by RT. And log A here, and that is called logarithm of A. A is ARRHENIUS parameter. So, intercept is this log A and slope equal to minus A by 2.303 R. Knowing the value of slope, gas constant, activation energy can be calculated from the formula slope equal to minus EA by 2.303 R. And here do one thing, you get the value of slope in your graph. So, EA equal to minus 2.303 R into slope. That means you should know slope and you should know R gas constant. EA can be calculated. And here when you draw the graph, plotting the graph between log K versus 1 by t, then here slope equal to minus EA by 2.303 minus EA by 2.303 R. From this you can calculate EA also. When the activation energy, that is EA, increases, the value of rate constant decreases. Remember, in the formula also you can find the activation energy and increases, the value of K decreases. Here one side K is there. So what happens? When the activation energy of EA increases, the value of K decreases, so the reaction rate decreases. Collision frequency, the number of collisions that takes place per second per unit volume. That means it is represented by Z. What is the number of collision that takes place in per second per volume? Effective collision means the collision which is very, very important, which are responsible to give the product, that is called effective collision. So many collisions are there, but which are effective, and that is only the giving product, that is called as effective collision. And here the increase of reaction rate, when rate is increases with the rise of temperature, it is not due to total number of collision but due to effective collision, because total number of collisions are not responsible for the rate. Here the molecules which undergoes giving product, that is called effective collision, and here the effective collision number is more and more, then rate of the increases. Rate of reaction increases. So remember, effective collision is very important. The reaction rate almost, when you compare to temperature, it is observed reaction rate almost becomes W with 10 degree rise in temperature. If 10 degree rise in temperature, the reaction rate just to double. Temperature dependence of the rate of reaction. That means temperature has many so good effect to the rate of reaction. In most cases, the reaction rate becomes double. Just now I told reaction is double by increasing of 10 Kelvin. And here temperature coefficient equal to rate constant at 310 K, rate constant divided by rate constant at 300 K. That means there is a 10 Kelvin difference. So this is called temperature coefficient. rate constant, if you take 310, that is the upper value, divided by rate constant, lower value at 300 Kelvin. And here also you can find calculation of with different temperature. Calculation of EA. Now only one temperature before that we have seen, but here two temperature. K1 is the rate constant temperature T1 and K2 is the temperature T2. Then what is the value ln K1? Ln K1 mean when not it is rate constant 1, it is here K1 is the temperature T1, and here you can find, you put the value and K1, K2, then you make minus scale ln K2 minus ln K1, you will get the value ln K2 by K1 equal to EA by RT1 minus EA by RT2. So T1, T2, there are two different temperature, and corresponding that rate constant, that is for T1 it is K1, if T2 that is K2. And here ln K2 by K1, and now we are not giving the value of 2.303, and this is EA by R 1 by T1 minus 1 by T2 whole bar. So here if you put 2.303 value, then it becomes log K2 by K1 EA by R, but here it is multiplied by 2.303. T1 by, if you make a minus, T2 by T1 minus T1 by T1 T2. Again see, if you remove ln and put log, then log K2 by K1 equal to EA by 2.303, and this is R. And here T2 minus T1 by T1 T2 whole bracket. EA can be calculated by giving the value K1, K2, T1 and T2. ARRHENIUS equation is a theoretical equation, and it is relation between the temperature and rate constant. Remember, ARRHENIUS equation is a theoretical one, and here it is a relation between temperature and rate equation. It is based on two theories, that is collision theory and reaction rate. Collision theory, and what are the collision theory? That effective collision, and depends on the collision of the molecules, and it depends on the orientation barrier. And so factor E to the power minus EA by RT, the fraction of the molecule which have kinetic energy greater than EA. This factor, remember, E to the power minus EA by RT, and here the fraction of molecules which have kinetic energy greater than EA. K equal to A to the power A E to the power minus EA by RT, and here there is ARRHENIUS equation. Here K is positive. So exothermic reaction or endothermic reaction here increases with rising temperature. Activation energy always gives the measure of rate constant. So activation energy and rate constant both are interrelated. So I hope it is clear to you about activation energy, ARRHENIUS equation, relation between activation energy and temperature, for both temperature, how it is related to rate constant. If it is T1, one temperature, rate constant is K1. If the temperature T2, the rate constant is K2. Here also you can calculate by using all factors, you can calculate the energy of activation. So I hope it is clear to you. Thanks for watching my video, and thanks again myself B.L.DASH, ex-PGT Chemistry, Kendra Vidyalaya Sangathan. Thanks to you again.